で、ブラックベルアーキテクチャのプラットフォームになってます。で、空冷式の HGF-B300 ですね。16GPU を NVD につないでいます。で、これがサーバーに搭載されるモジュールとなっていて、AI 発電の基盤となっています。で、真ん中の2つがですね、NVL72 というラックスケールのシステムの中のトレイとなっております。こちら2つとも水冷式ですね。で、左のものが NV リンクスイッチトレイとなってまして、プロセッサーをつなぐためのインターコネクトを提供します。で、こちらコンピュートトレイですね。コンピュートトレイ、計算のためのトレイとなっておりまして、4GPU、2CPU を搭載した、グレイス・ブラックウェル・ウルトラのですね、アーキテクチャのものとなっています。ちょっと新しいものです。このトレイをラックに搭載することで、ラックあたり 72GPU、144の GPU 第1の構成を取ることができます。そしてもう一つ今回コンピューテックスで発表したのが RTX Pro 6000サーバーエディションを搭載したサーバーです。1台のサーバーに8つの RTX Pro 6000を搭載することで、AI のトレーニングからファインチューニング、そしてデジタルツインのシミュレーションやグラフィックスまでマルチにお使いいただけるシステムを構築することができます。お客様のニーズであるとか、コンピューティングの規模によって、いろんな構成を取ることができますが、その上で動くソフトウェアは共通なので、そうですね、小さく始めて大きく拡張するということも可能でございます。で、こちらに進んでいただくと、こちらはですね、そのラックスケールシステムの次世代のもの、カイバーと呼ばれるもののモジュールとなっております。今、現行のものはオベロンというものですが、2027年、再来年にカイバーのものになりまして、より高密度で電力効率を高めたシステムになります。27、はい。ルービンウルトラの世代ですね。で、こちらはネットワーキングのコーナーになっておりまして、我々、イーサーネット、そしてインフィニバンドのスイッチであるとか、その中で動く ASIC、NIC 等がですね、開発を行っております。今年の GPU ではコパッケージドオプティクスというですね、フォトニクス技術を使って、直接光ケーブルを装着できるというものを開発し、より電力効率を高める、そのようなですね、半導体からこういった、システム、ネットワーキングまでのですね、トータルのフルスタックのですね、開発官といってますか、プラットフォームを NVIDIA が提供して、AI ファクトリー、データセンター規模のものをですね、構築できる、そういったものを提供しております。で、こちらがインフィニバンドですね、クォンタム X。で、右側がイーサーネットのスペクトラム X でございます。で、データセンターのハードウェア、こちらの紹介なんですけど、紹介がつきまして、ブラックウェルをですね、手元のデスクトップで動かすためのパーソナル AI スーパーコンピューター DGX Spark です。3月の GTC で発表しまして、この度の、コンピュテックスでは、参加パートナーのですね、拡充を発表させていただいております。非常に小さな、ハードウェアの中に1ペラフロップスの AI 性能をですね、128GB のメモリを搭載することで、大規模の AI もですね、このような小さなホームファクター上で動作させることができます。手前のが NVIDIA として提唱する、あとはパートナーさんが提唱する、2つをつないで、より大きな AI を動かしますように、EGX ステーションとしてのご利用もいただけます。で、ワークステーションの筐体の中にグレイス CPU とブラックウェルウルトラ GPU を搭載しまして、20ペタフロップスのですね、AI 性能を発揮する、で 768GB のですね、統合メモに搭載して、より大規模な システムを手元のデスクでですね動かすことが可能となります。こちらの DJX ステーションは NVIDIA のブランドとしての販売はなく、OEM パートナー様からの販売です。こちらスーパーマイクロさんのものです。他のメーカーさんのものは後ろの方にもございます。こちらが AC スタジオですね。でぐるっと回っていただくと MSI さん、そしてこの裏側にはギガバイトさんのものがあります。で先ほどご紹介したデータセンターと共通した OS、そしてソフトウェアが動作しますので、手元で開発してクラウドで大規模に展開するであるとか、クラウド上でトレーニングしたものをそのまま手元の DJX で動かす、そんなことも可能。ソフトウェアの互換性があります。でこういった環境で、構築するのが AI エージェントであったりフィジカル AI なんですが、その代表的なものをですねいくつか並べておりますのでご紹介できます。
So this is our Isaac for Healthcare demo. So Isaac platform is for robotics. So here we have a robot arm, and our task is for the robot arm to learn how to align this robotic arm with the vector that is pinpoint. So this vector is there, so now it's trying to rotate and attach itself to that point. Right? So that is one robotics used, and then once we have that model, we can then apply it to other places, like this one. This is a robotic ultrasound. So once we have that robotic arm model, we can then ask the AI to learn how to scan ultrasound and find out what organ they want to scan. So imagine this. This is ray tracing with ultrasound. So when the robotic arm comes down,
Can you speak out a little bit louder?
when the robotic arm is scanning, we'll have a ray tracing, right? And then the ray traced image of the ultrasound will be provided for the robot, and then the robot will be able to know what's going on inside the phantom. Now, then the robotic arm can learn how to find which organ they want in the ultrasound. And here we have a robotic arm trying to pick up the suture thread. So since the thread is over there, we can have the robotic arm learn to look for the thread and pick it up. And then the last one is this surgical VLM. So with this, we can play a video of a surgical procedure, and then with the surgical procedure, we can then ask it questions in this chat window, and then it can also do annotations. So like in this video right now, it sees grasper, it sees scissors, it sees gallbladder, and liver. And then we can also ask it questions like what and then it will answer in the system, and we will provide it probably use tools in the surgery. And then we can also make it take a note. So note, we need to do a careful dissection versus the area, and then it will take a note, and then it will also mark the place as 514. And then it will here with a note. That's it.
こちらはですね、今ヒューマノイドをはじめとしたロボットのトレーニングのためのですね、データを作るためのところの、ものとなっています。主にバースを使って仮想空間上でロボットの動きで再現し、その映像をコスモスという、生成 AI のパワーを使ってさまざまな環境のものにですね変換することができます。で一つのデータをたくさんのデータに、増やすことができるので、さまざまな環境に、ちゃんと適応するロボットトレーニングのためのデータをですね構築することができます。で、今回こんなものがありまして、今回初だそうです。何でしょうと言いますと、ジェットソン AGX そうですね。新しいSoC を搭載した次世代のエッジ向け、ロボティクス向けの、コンピューティングプラットフォームとなっております。仮想空間上でデータセンター上でしっかりとトレーニングをした AI を、実際にこのですねエッジデバイスに持っていって動かすことができます。これデモコードだと思うんですが、はい、いろんなインターフェースを用意してさまざまな用途の開発に使いいただいています。でこの、裏こういう向きは
させらんない
させない。
そうか確かに。でもロゴの位置的にはこうなんで。
ここのところにですねベースも、PCB があって基板があるんですが、こっち左側はクーリングのためのものですね。データセンターからエッジまでのですね、ハードウェアそして、ソフトウェアのプラットフォームですね、フィジカル AI に向けて我々構築し提供しております。で右側がロボットへのラーニングのためのですね、人間が、デモンストレーションを行ってヒューマノイドに動きを教える。で人間がたくさんの動きをですねデモンストレーションするのが非常に大変なので、いくつかのデモンストレーションの動きを見ることに AI がたくさんのデータを生成するので、フィジカル AI に必要な膨大なデータを、構築が可能となります。頑張ってます。シミュレーション上で、たくさん練習をすることでさまざまなスキルをですね、身につけ洗練させることが可能となります。そのための我々ハードウェアソフトウェア、そして我々もですねデジタルツイン、実際に活用しております。で AI ファクトリーを構築のためのデジタルツインです。膨大な計算リソースを、実際に現地で構築する前に仮想空間上で、設置をしシミュレーションをする、電力であるとか熱であるとかさまざまな、シミュレーションをしてちゃんと検証済みのものを実際に立てる、することで構築前の時間が減ったりであるとか、あとはしっかりと、トラブルなく動かすことができます。あとは動かしている間の状態もモニタリングを行うことで、生産性をできるだけ落とさないようなコントロールですね、より最適化ということも行います。
So what we've done here is we have built one of our data centers, NVIDIA data centers. We have two purposes with this model. First one is to build a framework to when we build new data centers to understand what requirement, right? The second part of this is that we actually look at the operational data that we have in our data center that we've run and visualize that. So when we look at the new data center, we can understand the kind of pod sizes that we want. Right, so we can start adding configuration here and you'll see that the pod changes. We can change the kind of temperatures or all the other parameters like the size of the electrical that we need, and you'll see that things will update. And when we start configuring this, the quite important thing here is to understand the cost of ownership, total cost of ownership. So we know if we're going to configure it in a certain way, this is the ownership and this is the requirement to be able to operate the data center. And we can, for example, go to 1152 GPUs. So you see it's a much denser rack. And we can run in the top view, for example, and switch off the ceiling. And we say here we only have one row at the moment, or we can go and add 3 rows, or we can go and add 4 rows, for example, and you'll see the updates of the parameters over here. Right, so that's really cool for configuring and understanding the sort of impact of the data center. Now when we go back to one of these views, for example, we can then go and say, well, let's see if this is the data center we want, let's see if we can run some tests. So right now we're showing that we are running a fail rate of 0 and we are load capacity only 25%. Everything's green, which means it's kind of de-energized. It's not really using efficiency, so it's over efficient. We can start increasing that, right? And you'll see that it will start changing the parameters. Everything starts going red, which means it's actually fully energized. This is a good state to be. right? And if we're going to rate our failure rate higher, you probably see that we're going to start going into a fail factor of this. And we can do this for the power failure, we can do this for the CDU failure, and we can do this for the chiller failure as well. Right? So the chiller failure, for example, here you'll see we do a graph. I understand based on the load when it's going to fail and then correct itself. So first of all, we start planning it, understanding the impact of it, then we can start applying load on the virtual model to see when it's going to fall over based on the requirement. And then we're done with that, we actually go and we can go and simulate our model. Right? So when we simulate the model, this is based on real data from last year, from October to December, taken every 30 minutes on every rack. And if I simulate that, what it will do, it will color each of the servers based on the model that we were training on it. So you can see here the CAE model, which is kind of showing over there, the large language model, the EarthDew models. They've all been computed last year, but we can visualize the load on each server rack, which is pretty cool. I wanted to show you as well that this is a fully detailed model. This is a full operational model. So if we go to like a view like this, for example, and we add say the 2 rows here, it has all the detail inside this model. So just give me 1 second to correct itself. Even down to the pins. This is our engineering model, right? We don't decimate. We take design to manufacture engineering models to operational models. So, and we're using this in the future to help plan our new data centers. So, from the planning point of view to the operational. So, and I just want to show you quickly here one more thing, is that if you go to a view like that, for example, and we switch off the containment and we switch off, say, the racks, we can even go and simulate the thermal, right, inside of this. And we can say that's very loaded, that's loaded 100%. But if we reduce the load, you can see that it's now showing us the reduced load and that is more operational to run. And you can do this, it goes all the way through the actual racks itself. So you can see it goes all the way into the racks, the thermal of this. So that's in a nutshell. That's
So how many GPU do you use this simulation?
to run this?
Yeah.
1 GPU.
Just 1 GPU?
Yeah, it's running off here. Yeah. This is running through a browser, right? If you go to build.nvidia.com, you can run this on your phone or any device because it's running on 1 GPU in the cloud. But this is running 1 GPU.
Yeah, because it looks like a SIM data center.
It is a
Like a SIM city.
yeah, exactly, and it's very high detail.
Yeah.
So 100%.
It's pretty.
You remember, the more we scale the GPU, the more memory we have, the more compute power we have. But this can run on 1 GPU.
Yeah, I want to play this game.
RTX 6000 Pro. This game makes money, right? This game makes money.
Exactly.
Yeah. So,
Yeah. Okay. Thank you
right,
so much.
thank you. Thank you very much.
So here we're showing the result from different EDA tool, ANSYS, Cadence, or Siemens, or Synopsys. Once different part of engineer, they have the certain result. Maybe it's electrical PCB, like maybe they got the result from PCB thermal, and our mechanical engineer, they're going to place the fan, and the thermal engineers want to evaluate the thermal design of the solution, so we can all accelerate individually in the EDA tool. But once we import it in the Omniverse, we can also accelerate together to evaluate much efficient way. So every part of engineer, they understand what of the result impact to in another aspect of the design. So the thermal engineer will understand how is the difficulty to move around the thermal design to impact the PCB design, or the PCB engineer understand the placement of the component will impact a certain amount of the heat dissipation and the thermal airflow. So in this way, we can have more efficient way to understand different language, to understand how to efficiently communicate it in the common language through Omniverse.
Okay, pretty good.
And we also do this in our GPU in 40 series, 50 series. We also try to improve a lot of constraints through the cooperation of different teams. So this is very efficient.
So in this, we are demoing how to use QOps, the library in a supply chain situation. So QOps, we ported the traditional linear programming optimization solver to the GPU, so we can compare with the CPU. We can speed up by 60 times faster to 240 times faster. So this is a typical supply chain issue. We have chip maker, we have assembly, packaging, and all the system makeup. And so when and we combine with the LLM model. So the LLM model will understand our question of the supply chain. If one of the costs of the manufacturer remains 10%, and it will generate the input for the QOps model, and the QOps model will give you the optimal result in a very short period of time. So it's to speed up all your decision making with all the actual simulation results. So that's a very powerful way for optimizing the supply chain issues. And this is just the demo of the supply chain, and you can apply that in all kinds of similar issue to find the optimal result.
It's about 5 minutes for simulation.
Yes.
Yeah.
So we are Pegatron.
Oh, Pegatron.
Here it shows how we build our AI factory for our company. So here it looks like the same, similar to our real factory. So the idea for we build a digital twin is to connect from the virtual and the physical together.
Yeah.
So the data will from the production line, real production line machines, and send back to the real world.
Oh, I see.
Yeah, and we can do the simulation and optimization here before you apply to production line. And here is we use the large language model to can use let the operator simply to type what he wants. You can check the status of the machines, and also to tell the actions to switch the camera in the virtual world. And furthermore, when the physical world and the physical machines have problems, we can teach the operator how to fix the issues in the virtual world.
I see.
Before he really do the action in the physical world. Yeah.
Oh, pretty good.
Yeah. So
Yeah, I think its name Pegabus is a very nice name.
yeah, Pegabus is our platform.
Yeah.
It's built on top of the Omniverse. Yeah. And this is very simple demo. So we have more demo in our Computex.
Okay.
Yeah.
After that, I will start that.
Yeah.
Thank you so much.
Okay. Thank you.
Okay, so this NVIDIA Digital Cloud Lepton is a new software that we announced at the GTC Taipei, and the Lepton is meaning for reduce the AI developer to use the GPU instance. We need to reduce the build environment time for users. So there you can see we can start from which region or which GPU instance resources we want to run from. So for example, here we have Nebulous, we have Lambda, we have Iota, that you can choose from a different region or different NVIDIA Cloud partner here. So for example, we want to rent some GPU resources from the Iota here, so we can we have many ways to do that. For example, we can bring your own account once you already have Iota's account and you have some resources here. You can just bring your own account here, or you can on demand. You can also rent different resources from our different partner here. And once you rent some resource here, you can skip to here. Also, sorry. The next step is to choose which GPU you want to use. For example, we want to select the H100 or A100, depends on which cloud resources you want to use. Then the next step is for the AI developer, they mostly develop their own job under container environment, so they can choose which container they want to use. So either they can provide their own container, or they can pull the public image from, for example, from the Docker Hub or from the NVIDIA NGC Cloud. Anyway, they can choose their own environment here. And once they prepare their own image, you can access the environment by SSH or access by the Jupyter Lab by one click. So, for example, we can, maybe choose to here. So, for example, we can click the Jupyter Lab. It will direct you to the web UI, which already inside this container. And our NVIDIA Cloud Partners infrastructure are all use NVIDIA reference architecture, which means their infrastructure are all optimized and same as NVIDIA's infrastructure. So under this infrastructure, users can easily to run multi-GPU job, and multi-node, multi-GPU job is works as well. So they can doing the large-scale model training here. And once the user have a trained model here, they can also deploy an endpoint. The endpoint meaning like you can deploy NVIDIA NIM, which is NVIDIA Inference Microservice here. So you can deploy your NIM container here, and it will pop out an endpoint here, and you can test your LLM service here. So you can have a playground here, just like you are using the ChatGPT. You can send some question here, but if you want to know how to send the API to your LLM service, you can. There is the API table. You can also use the API table to send the request by using API to your LLM service. Yep. So those functions for render GPU resources and deploy container, deploy service. There you can see we are not quite really need IT specialists in front of this environment. For example, if a startup or a small company, they don't have too much IT specialists here, but they want to run cloud service. For example, they run some GPU resources from the AWS or GCP. They still need to hire some IT specialists to manage all the GPU instance here. But through the DGX Cloud Lepton, as you can see, we don't really need that much IT specialists here. So you can just run some resources and deploy your own environment. Then we can start to run the AI development job or training or service, something like that. Yeah.